This is a key to the worksheet on solving log equations. And so let's go ahead and look at number one. And in number one, we have this log equation. And so we have the log of x plus 1 base 2 plus the log of x minus 1 base 2 equals 3. Now, when solving a log equation, keep in mind from the lessons that you've studied that you need to isolate the log expression. And so you may need to use the properties of logarithms to create one logarithmic term. So in each of these problems, that's what you're going to have to do. See, on this side, you have two log terms. You have to make sure you use those properties to get one of those. So you're going to use those properties to make this one term. You're going to use the properties to make this one term, and so on. Okay? And so once you write it as one logarithmic term, then you're going to rewrite it in exponential form. And then once you write an exponential form, you're going to solve for the variable. Okay? Now, keep in mind that the properties of logarithms that you're going to use for the most part will be in some of these problems. In some of these problems, you're going to use the one-to-one property. So we're going to look at this one. You're also going to look at the multiplication property of logarithms, and so we're going to look at that one as well. We're going to look at the division property, and we're going to look at the power property, probably. I think there's one that deals with this, and we're going to look at the inverse property. All right, so we're going to talk about these properties as we go through these log equations. All right, so let's look at number one. So number one, again, I'm adding two logs. Notice I have to have the same base. Keep that in mind. So if these bases were not the same, then we could not use these properties here. All right, so these properties only apply if the bases are the same. Okay, so to write this as one log expression, remember you got to write it as one log expression. That's the next step. Since I'm adding, since this is addition, I'm going to use the multiplication property. All right, so let's talk about that. So let's kind of review the multiplication property. So the multiplication property of logarithms, says this: if you have the log of a product, log of xy, with some base b, then I can rewrite this as the sum of two logs with this base. So it'll be the log of each of those factors. So it'll be the log of x base b plus the log of y base b. All right, and so you can go from the log of a product to the sum, or you can go from the sum to the log of a product. Okay, so you can expand or you can condense. Okay. So in some of the lessons, remember you talked about the word expanding, and you had some lessons with the concept of condensing. All right, so I'm going to use this property here because that's addition. See, addition. So I'm going to write this as one logarithm. So when you have the sum of two logs with the same base, you're going to write as a product. So this becomes the log of x plus 1 times x minus 1 base 2 equals 3. Okay? So that's what this is. So the sum of two logs can be written as one logarithm. And to do that, you're going to take the arguments, you're going to multiply them together. All right? Now the next step, so remember the next step, is to rewrite this in exponential form. Okay, so you got to remember, you have to remember that the log, so this is what we're going to use now. So the log base b of x equal y can be written as an exponential. So you take the base, you raise it to what's on the other side. See, b to the y equal the argument. All right, so that's one of the things that you learned in the lessons. So what that means then is this: 2 to the third is going to equal this product, the argument. All right, so I have x plus 1 times x minus 1 is going to equal 2 to the third. Okay, and so let's go ahead and multiply this out. So now we got to solve for the variable, right? So now I'm multiplying two binomials here. So let's go ahead and multiply this out. So x times x is x squared. The outer is a negative x. The inner is a positive x. And the last, positive 1 times negative 1 is a negative 1 equals, and then 2 to the third is 8. Subtracting 8 from both sides, notice this is quadratic equation. So subtracting 8 from both sides, I get x squared. The x's, when I combine them, adds up to be 0. And a negative 1 and a negative 8 is a negative 9, equals 0. All right, now notice I can solve this quadratic equation either by using the difference of two squares by factoring, or since there's no x term, I can bring the 9 to the other side, just like this, and then take the square root of both sides. Remember, when you do that, you get plus or minus. So I get x equals plus or minus 3. Okay? All right, now remember that our properties of logarithms only applies if the base is positive and also if x is positive. Okay? So I can only take the log of a positive number. Keep that in mind. I can only take the log of a positive number. All right? And also remember that the base cannot equal 1. All right, but so remember, you can only take the log of a positive number, so you got to check this. You can't say that those are both your solutions because they may, one of them may work, one of them may not work, or they both may not work. All right, so always go back to the original equation. All right, so you must check your solutions, and basically all you do is go back to the original problem and make sure that the argument is positive. You can only take the log of a positive number. That's one of the lessons that you've learned. Okay, so let's check 3. If x equals 3, let's see if 3 will be fine. 3 plus 1 is 4. 4 is positive. 3 minus 1 is 2. 2 is positive. So if it did all this work correctly, then 3 will be a solution. Let's check if x equals negative 3. Negative 3 plus 1 is a negative 2. So right away, I know that I can't take the log of a negative 2. That's undefined. I can only take the log of a positive number. All right, not even 0. So that will not work. So the only solution is x equals 3. Okay? All right, so that's one of the things that some students forget to do. They come to this point here and they say, okay, those are my solutions. But remember, you're dealing with logarithms. You can only take the log of a positive number. So these arguments must be positive. Okay? All right, so that's number 1. So number 1, the solution is x equals 3. There's your work. You must show the work. All right? Okay, let's look at number 2. So number 2, we have this equation. So this is number 2. So let's see. Here's number 2. We have the log of x plus 15 base 4 plus the log of x base 4 equal 2. Okay? All right. And so notice again, this is an addition problem, right? So since this is an addition problem, I can, if I can find it, I can go ahead and use a multiplication property. So when you have the sum of two logs with the same base, and the base is the same, then I can rewrite this as one logarithm. And so it'll be the log of this product. So it'll be the log base 4 of x times x plus 15 equal 2. So you're going to remember the sum of two logarithms with the same base can be written as one logarithm, but as you take the arguments and you multiply them. So that's your next step. So remember our steps is to write the use the properties of logarithms and get one log term on one of the sides, and I did. So I wrote these two logs as one logarithm using the multiplication property. Okay, so now I am going to use, let me go ahead and put that here. So now I'm going to use this property that when you have the log base b of x equal y, then you can rewrite this as b to the y equal x. So you can rewrite it as an exponential. Oops, that's a y, sorry. B to the y, oops, let me rewrite it. B to the y equal x. All right, so you can take a logarithm, you can write it as an exponential. So that's the next step. So remember, the next step is to rewrite it as in exponential form. So we're going to say 4 squared equals the argument. So x times x plus 15 equals 4 squared. Okay, so distributing this time, so remember number 1, if you look at number 1, we had to see here to multiply this out, we had to use FOIL here. Here, remember you got to solve for x, so I'm going to use the distributive property at this point. So x times x and x times 15. So I get x squared plus 15x equal 4 squared 16. Subtracting 16 from both sides, this is quadratic. So subtracting 16 from both sides, I get x squared plus 15x minus 16 equals 0. All right, and this is factorable, so I'm going to go ahead and factor this. So I get x plus 16 times x minus 1 equals 0. All right, and then using the 0 factor property, I'm going to say each one of these equal to 0, right? Well, let me write it. It's x minus 1 equals 0. And then I'm going to solve each of those linear equations. So x equal negative 16 and x equal 1. Okay, now remember, some students forget about this. Both of these may work, both of these may not work, one may work. All right, so you got to check them. So remember, you can only take the log of a positive number. So go in here, take that negative 16, and see if both of these are going to be positive. Well, right away, you know that negative 16 plus 5 is a negative 1, and you cannot take the log of a negative number. So right away, this will not work. Okay, so this makes at least one of the arguments, in this case both of them, negative. Makes the argument negative. And remember what I mean by argument, this whatever you're taking the log of, we call that the argument. Argument negative. And so remember, you can only take the log of a positive number. Now let's check 1. 1 plus 15 is 16, that's positive, and then this argument 1's a positive number. So that's the only solution. So x equal 1 is the only solution. Okay? All right, so that's number 2. So it's not a difficult concept. You're just using the properties of logarithms. Okay, so let's look at number 3. So number 3, we have this for number 3. We have the log of x base 6 minus the log of x minus 3 base 6 equal 1. Okay, now this time this is subtraction, so you got to be careful. What we were using the previous 2 was addition, so we're using the multiplication property. So this time we're going to use the division property. See subtraction? Okay, so let's talk about the division property. So let's review this. So you learned about this in a previous lesson. So the division property of logarithms, sometimes called the quotient property. Logarithms. Let me put an S here. Okay, logarithms. All right, so basically it says this. And I'm going to write it. I'm going to write something like this first. I'm going to say the log of x base b minus the log of y base b can be written as one logarithm, and you're going to write like this: a log of, so it's going to be quotient, division, quotient. Whatever's listed first, you put that in the numerator. So x divided by y base b. Okay? So the sum of two logs becomes a product. The difference of two logs becomes a quotient, a division problem. All right? So here we go. So difference, quotient. So the first thing you're going to do is you're going to write this as one logarithm. That's what you have to do always. So you're going to say the log base 6 of the quotient. Whatever's listed first, the first argument is the numerator, the second one is the denominator. So x divided by x minus 3 equal 1. Okay? Now, once you do that, once you get to that step, remember, once you get to that step, now you're going to write it in exponential form. So meaning in all these problems, almost all of them, you're going to see that it's almost all of them, you're going to go from log form to exponential form. So you're going to say 6 to the first power is equal to this. So we get this, x divided by x minus 3 equal 6 to the first. And let's go ahead and rewrite 6 to the first as 6. So I get x divided by x minus 3 equal 6. All right. Okay, so now we have this rational equation. So I went from a log equation to a rational equation. And to solve this rational equation, I'm going to go ahead and multiply both sides by the least common denominator. So the least common denominator is x minus 6. X minus 3. So x minus 3 times x minus 3. All right? And so these will divide out. Remember, that's the whole purpose of multiplying by the LCD is to get this fraction here, or this denominator, to have a factor of 1. So 1 times x is x, equal, and then distributing here, I get 6x minus 18. Okay, and then let's go ahead and subtract 6x from both sides. So notice this is linear. This is linear, right? The one we did in the previous problem, when I got to that point, that was quadratic. All right, and so notice this is quadratic. This one's linear. So subtracting 6x from both sides, 6x minus 6x is a negative 5x, equal, this is 0, negative 18. Dividing both sides by negative 5, I get x to be a positive, negative divided by negative is a positive, so I get x to be a positive 18 fifths, which is, as a mixed number, is 3 and 3 fifths. Okay? Now always check to make sure, remember you got to check to make sure that the argument's going to be positive. So if this right here made the argument negative, then this would have no solution, because that's the only proposed solution you see. So notice positive 3 and 3 fifths, right? So this is going to be positive. 3 and 3 fifths is positive. 3 and 3 fifths minus 3 is 3 fifths, and 3 fifths is positive. So this is going to work. So this works. So the solution is x equal 18 fifths, or you can say 3 and 3 fifths. Okay? So that was number 3. So number 3, we had to use the quotient rule, or the division rule, to get this written as one log term. Okay, number 4. So let's go to number 4. So in number 4, we have this equation. We have the log of x plus the log of x plus 5 equals the log of 6. All right, now remember, so again, now notice right here it says to solve most log equations. I did use the word most, and so when we get to this point, you're going to see that I am not going to use the second step, and you're going to see why. So first of all, let's go ahead and write this as one log term. Notice there's no base there, but you know that it's understood to be base 10, right? So this is a common logarithm, and notice all the bases are the same. Base 10, base 10, base 10. So this is a sum. So I'm going to write this as a product. So this becomes a log of x times x plus 5 equals the log of 6. Now notice that in the previous three problems, on the left side, you had log terms. See that? On the right side, on the previous 3, you did not have a log term. This one did. This one does. All right. So now what we're going to do is we're going to use this one-to-one property. So one of the properties you learned in the lessons was this one-to-one property. So the one-to-one property says this now. So let's go ahead and write that down. So the one-to-one property, says this. If the log of y base b equals the log of x base b, so if you have two logs equal to each other with the same base, all right, log on each side, and that's what we have here at this point. See this right here? We have two logs with the same base equal to each other. Then y must equal x. So the arguments must be equal to each other. So what that means then is that this right here must equal 6. So this argument must equal that argument. So using a one-to-one property, so remember this is a one-to-one property now. Okay, that's what we're using. So the one-to-one property says that x times x plus 5 must equal 6. So that's why I said in here to solve most, because for this one, you're not going to change it to an exponential form. You're still going to use step 1, but you're not going to use step 2, because step 2, we're going to use the one-to-one property instead. So that's where notice I did not change this to an exponential form. Okay, I just said this argument must equal this argument because I'm taking the log of both sides, and the bases are the same. So now I'm going to go ahead and distribute, and so I get x squared plus 5x equals 6. Notice this is quadratic, so let's bring the 6 to the other side. So x squared plus 5x minus 6 equals 0. Factoring, I get x minus 6, x plus 6 times x minus 1 equals 0. And setting each factor equal to 0, I get x plus 6 equals 0, x minus 1 equals 0, and so x equal negative 6, and x equal 1. All right. Now remember, you got to go back and check to see if any of these proposed solutions makes my argument negative. So look, right away, you know the negative 6 is not going to work because this argument's negative, right? Log of negative 6, you know it's not possible. That's undefined. Same thing here, negative 6 plus 5 is negative 1. So right away, you know this is not going to work. So let's be careful. You always got to check one. You got to check both of them. 1's positive, 1 plus 5 is 6, and that's positive. So that one's going to work. So the solution is x equal 1. Okay? All right, so that's number 4. See, it's not difficult. It's a very, very simple process to solve these log equations. Okay, number 5. So in number 5, we have the log of x plus 4 base 7 minus the log of x minus 4 base 7 equals the log of 5 base 7, right? Okay, so notice again, you have logs on both sides, but the first step you have to do is make sure you write see how you have 2 logs on one side? You want to make sure you write it as one log term. So that's subtraction, so we can use the quotient property or the division property. So the base is the same, so I can say the log base 7 of the quotient. So x plus 4 divided by x minus 4. X plus 4 divided by x minus 4 equal the log of 5 base 7. And so remember, you have to know which property you're going to use now. You have the log of this with base 7 equal the log of 5 with base 7. So notice on both sides you have the log base 7. So right away I can use the one-to-one property. So when using a one-to-one property, I'm going to say x plus 4 divided by x minus 4 is equal to 5. So that's a one-to-one property I'm using. You need to see this. You need to understand that. One-to-one property. So x plus 4 divided by x minus 4 equal 5. And so just like we did in, I think it was number 3. Yeah, so number 3, just see this right here, looks like this, right? And so I'm going to multiply both sides by the LCD, which is x minus 4. So the LCD is x minus 4. So let me go ahead and rewrite this over. Okay, so multiply both sides by x minus 4 times x minus 4. And so when I multiply by x minus 4, these factors divide out. And so you get 1 times x plus 4 is x plus 4 equal, and then distributing here, I get 5x minus 20. Notice this is linear. So I'm going to subtract x from both sides. And so when I combine like terms, I get 4 equal 5x minus x is 4x minus 20. Add 20 to both sides. I get 4x equal 24. Divide both sides by 4 to get x by itself. I get x to be 6. All right, so you got to check that though. Make sure that when x is 6, my argument is positive. So you always go back to the original. 6 plus 4 is 10. 10 is positive. 6 minus 4 is 2. 2 is positive. And notice you didn't have to do this one because there's no variable here. That's always positive. 5 is always a positive number. So this works. So the solution, that's a little check mark. The solution is x equal 6. Okay? All right, let's go to number 6. So number 6, we have this equation. All right, so this number 6. So we have the log of x plus 25 base 3 plus, oops, sorry, that's minus the log of x minus 1 base 3 equal 3. Okay, so notice that I have the difference of two logs, but the base is the same. So I'm going to have to write this as one log term. So since that's a subtraction, I'm going to use a quotient rule or the division property. And so that becomes the log base 3 of x plus 25 divided by x minus 1. So I'm using the division property of logarithms. Okay, so it becomes x plus 25, that's a 25, divided by x minus 1 equal 3. Okay, so now see that this equation only has one log term. See, there's no log term here, so therefore you're forced to change it to an exponential now. So you now have to use step 2. Okay, so 3 to the third equals the argument. So the argument, x plus 25 divided by x minus 1 equals 3 to the third power. 3 to the third is, what's that, 3 times 3 times 3, so that's 27. So I get x plus 25 divided by x minus 1 equals 27. All right, so now I'm going to multiply both sides by the LCD. So the LCD is x minus 1. So x plus 25 divided by x minus 1 equals 27. So times x minus 1 times x minus 1. Okay, so these x minus 1s divide out. So you get 1 times x plus 25 is x plus 25 equal, and then distributing the 27, I get 27x minus 27. Subtracting x from both sides, I get 25 equals 27 minus x is 26x minus 27. Adding 27 to both sides, I get, see, this is linear, so I'm going to get 26x equal, and then 25 plus 27 will give us 52, right? And dividing both sides by 26, I get x to be, that's 2. Okay, now you got to check this now, right? So you got to go back and make sure that the argument is positive. 2 plus 25 is 27, so that's fine. 2 minus 1 is 1, 1's positive. So this is going to work. So the solution is x equal 2. So just to remind you, see how you only had one proposed solution? If that proposed solution made one of these arguments negative, then you would say no solution. All right, and then finally number 7. So let's do number 7. So number 7, you had, let's see, you had this log equation. You had the log of x minus 5 base 9 plus the log of x plus 3 base 9 equal 1. So that's the sum of two logs. So remember the sum of two logs. You can use the multiplication property. So this is going to be, so you're going to write this as one log term. So remember that is step number 1. Write as one log term. So it becomes the log base 9 of x minus 5 times x plus 3 equal 1. All right, so notice you only have one log term. You don't have a log on this side, so you are going to have to now change this log equation to an exponential. So 9 to the first equals this product. So x minus 5 times x plus 3 is equal to 9 to the first. Okay, so using the FOIL method here, I get x times x is x squared. The outer is 3x. The inner is a negative 5x. And the last, a negative 5 times a positive 3 is a negative 15 equals, and then 9 to the first is 9. Combining like terms, I get x squared. 3x and a negative 5x is a negative 2x. Minus 15 equals 9. This is quadratic, so let's go ahead and subtract 9 from both sides. So I get x squared minus 2x. And a negative 15 plus 9 is a negative 24 equals 0. Okay? Okay, so now let's go ahead and factor this. So let's go ahead and factor that. So I get x minus 6 times x plus 4 is equal to 0. Setting each fact equal to 0, I get x to be 6 and x to be negative 4. But you got to check both of those, right? So go back to the original. So let's do the 6 first. 6 minus 5 is 1. 1's positive. 6 plus 3 is positive, right? That's 9. And so therefore this one's going to work. Now let's check negative 4. Right away you know negative 4 is not going to work no matter which one you put. So negative 4 minus, that was 5. So negative 4 minus 5 is a negative 9. And then also here, negative 4 plus 3 is a negative 1. So right away you know this is not going to work. All right, so the solution is x equals 6. That's the only solution. Okay, so that was, or that is the key to this worksheet on solving log equations.